Hey everyone, in this video we're going to be talking about how do we represent circles in terms of equations. Now this is important in a lot of specific situations. For example, in manufacturing, let's suppose that you have a sheet of metal, and in this sheet of metal we need a circle cut out that has a certain property about it, or properties about the circle. For one, we would want to know the size of the circle. That's really the only property that a circle can have, is its size. Now, after that, get this to go away, there we go. The next question would be, where is the circle going to be located at? So in terms of our circle, one thing that we're curious about is its size, and then where is it located at, so that we can refer to that. So, a circle here would be different than a circle over here. And a circle in either of these cases would be different than a circle this size down in the lower part. In either instance, it's important again to know what is the size of the circle and where is it located at, so that we can make sure that we're manufacturing that circle or cutting that circle out in a way that is advantageous to our situation. So an idea here is, when we're talking about circles, these are our two principal components when we're talking about the equation of a circle. We need an equation that will tell us the size of the circle and also its location. And in our situation, our equation tells us exactly that. The equation of a circle is represented in this type of an equation. Now, when we have an equation in this setup, you'll notice how I've written this in two different colors. The colors, or the components that are in blue, you can think about those as the parts that do not change in a simple term. The green parts are the parts that will change. Now, in our situation, how these connect to our conversation we just had about the equation telling us the size and the location, here's how that applies. If we think about the location of a circle, we will determine by where is its center located at. So in this equation that we have here, our center will be located at the point HK, based off of what's in my equation. Now, in terms of size, the size will be measured by the radius of the circle, and that's this component here. So the radius of our circle will be this number at the end, which is R. Now, that's a little bit arbitrary or vague, abstract, ever what you want to call it, because everything's in letters. So let's look at that in terms of an example. So if we have an example here, let's make it where maybe we have something like x plus 2 squared plus y minus 5 squared is equal to 9. Now, if you look at this, you'll notice how it follows this pattern that we just had up here in this equation. You'll see that we have our x, you'll see that we have a number, squared, plus, in parentheses, y, and then a number squared equals 9. Now, you may think, well, wait a minute, this one doesn't have a square on the end, and that's okay. What this means is that the number at the end here represents the radius squared. So when you're looking at this 9, you have to understand that that 9 represents the radius squared, or r squared. So with that in mind, it should be fairly easy for us to think about what would the radius be. If this number at the end is the radius squared, then that means that the radius squared is 9. And from that, we can then remove the square by doing the inverse operation by square root. Square root and square are inverses, so they cancel, leaving me with r is equal to the square root of 9, and the square root of 9 has a nice square root. It is 3. So that means that in this situation, the size of my circle has a radius of 3. So there's that first component. We figured out the size. The location, notice how the location, it comes from the center, which is these two numbers here. Now, one thing also to take note is, if you'll notice in this example, whenever I did this, we have that, let me get a different color here so we can look at this. this h has a negative in front of it, or a minus sign. Yet notice when it comes out as the center, it's a positive h. Likewise, the k had a minus in front, but it came out as a positive k. So when you're looking at the equation, the center's location will be the opposite of the number inside of the parenthesis. So what that means is that whenever I'm looking at the center of this circle will be located at a location where we take the opposite of this number, which would be a -2, and the opposite here, which would be a +5. And now we know the location of this circle. So with this equation that we have here, we have now figured out the two properties of this circle that would tell us how this circle exists, basically. Okay, so if we look at that in terms of graphing, and this is just going to be a sketch. I'm not going to do anything super specific here, but just a rough graph. I know that I have a center at -2, 5, which means that I'll go left 2 and then up 5. 1, 2, 3, 4, 5. So that would be the center. The fact that we have a radius of 3 means that my circle will exist 3 units out from the center in all directions. So I could say we're going to go 1 unit, 2 units, 3 units that way. I can go 1 unit, 2 units, 3 units this way. And I could do that in all directions. Now again, this is not going to be to scale because I'm just freehanding in this situation. And then that would give me a rough sketch of my circle. It looks more like an egg in this case, but you get the idea. So using that equation, we can figure out what are the properties of a circle and then be able to graph that circle. Now we could kind of flip that on its head a little bit, and instead of having the equation and then we figure out what the circle would look like, we could take information and then write an equation. So for example, suppose that I wanted to have a circle where I know that its center is located at +1, -4. And suppose this time I know that I want my circle to have a diameter of 4 units. So when you're thinking about our equation, remember our equation follows this format of x minus h squared plus y minus k squared equals r squared. Now remember, the center will be these components that go in here, but we have to change their signs. So as I'm doing this, I will go and do x. Since this is a +1 here, it will be -1 on the inside. Then the y part, it's a -4, so on the inside will be a +4. The radius, well, the diameter is 4. If the diameter is 4, then that means that the radius would be 2. So then if I take that 2 and plug it in, 2 squared is 4. There's my equation of my circle. Now those are two pretty simple situations, and sometimes it can get a little bit more involved than that. In this situation, I gave you the center, I gave you the radius, or I kind of gave you the radius. We gave you the diameter, which was easy to find the radius. So basically what you were given is almost exactly what you needed for the equation. Sometimes that's not the case. Sometimes I may have a situation where I know the center of the circle's location and I know a point on the circle. So this is a little bit hard to visualize, but if you can imagine that if this is the center and this is a point on the circle, that maybe this circle looks something, and this is going to again be a terrible representation because I haven't got it in the center. That looks awful. Okay, there we go. That's better. So suppose we have this situation where I have a point on the circle and then I know the center. And if I want to write the equation of this circle, well, in writing the equation of the circle, again, we must follow this pattern, or we must follow this formula that examines the equation based off of its center and its radius. Well, if you notice, we know the center here, so that's pretty easy to go ahead and fill in the gaps based off of what we already know. Can you figure it out on your own? Think about it, pause the video, and see if you can figure out what this part would be. Okay, here we go. It would be x, opposite of the x value, so +1, opposite of the -2, so that would be y plus 2. And forget my square. And then I need to know the radius. Well, notice that I do not know the radius of this circle. The radius is that distance from the center to the edge, or to center to the circle. We don't know that. There's nothing here that's giving me that. So what we're going to do is we're going to fall back to one of our prior techniques of using distance formula or Pythagorean theorem to figure that out. In this situation, I'm going to go ahead and do the distance formula. That was done at an earlier video. If you need, you can go back and look at that. So the distance formula is equal to the square root of x2 minus x1 plus y2 minus y1 squared. So if I treat this as, we'll call this maybe point number 1. Why is that not working? Let me get that. There we go. Let's call this point number 1, and we'll say this is point number 2. So x2 will be 3 minus x1, which is -1 squared, plus y2, which would be 1 minus y1 -2 squared. All right, clean this up. -3, a minus and a negative turns into plus, so 3 plus 1 is 4. 4 squared would be 16. Again, negative and negative become positive. 1 plus 2 is 3. 3 squared is 9. 16 plus 9 would be 25. Square root of 25 is 5. So that means that the distance from here to here is 5. So my radius is 5, and I can now bring this back up to my circle equation where I need to know the radius squared. That would be 5 squared, and if we're simplifying this to totally round it out and finish up, it would be x plus 1 squared plus y plus 2 squared is equal to 25. And that would be the equation of my circle. That would ensure that I have a circle at the correct location with the correct size or the correct radius. Okay, that is how we deal with circles and equations of circles. Good luck. Let me know if you have any questions.